Now, we have the pleasure to begin with our first presentation of today. For this, we call Edgar Daniel Salmerón-Carreño, which is here in representation of the team composed by Leonardo, Víctor, Hugo, Jerjes, Edilia, and José Guadalupe. He will present the paper entitled Indices and State of Vegetation Health Obtained with Multispectral Cameras in Two Thermal Springs of the Sierra Madre Oriental. Please give a warm welcome to Daniel.
Good morning, everybody. Can you hear me well? Perfect. My name is Edgar Salmerón. I'm coming here from Corporación Ambiental de México, which is an environmental consultancy firm. It's a Mexican firm, which almost 29 years old of history. And this is a joint effort between Corporación Ambiental de México and the Universidad Autónoma de Tamaulipas, and specifically the Instituto de Ecología Aplicada. Our work is called Indices and State of Vegetation Health, obtained with multispectral cameras in two thermal springs in Sierra Madre Oriental. Thinking about the last century, we have seen many improvements in technology by the use of satellites. The use of satellites is mainly being commonly used for those areas where there is hard to access and remote sites, and also where there is very high the cost of getting there and getting the collection of data. So the use of remote technologies, remote sensing, has been very commonly used and also with several advantages. For example, the low cost, but and also the time or the technology for that kind of collection of data. However, we can identify two disadvantages by the use of remote sensing. One of them is the time scale, which is when I get an image and I want to get another image somewhere after the first one, it could be difficult to get the same quality of image, and also the spatial resolution, which is the time of the size of a pixel, depending on the satellite we are using. So, given that, the unmanned aerial vehicles, the UAVs or drones, has been recently more accessible, not only for military purposes, but also for civilian purposes, such as you may see, for example, for agriculture, for health, the hospitals, traveling the parts of the body for transplants, for example, the study of forests and wildlife, and many other applications. So these vehicles have lowered costs, and also they have improved time and spatial resolution for several studies. The main or one of the great advantages of these vehicles is that you can go back and take the data collection within no time and with the same quality and resolution. They are very cheap. It depends on what improvements you make to those vehicles. For example, the kind of sensors that you use and the size of the drone or the UAVs. So these are well-known advantages we all know. Some drawbacks that we can take in account is that the only thing that you have to worry about is that your flight conditions are very optimal. So you have to take in account the cloud density, if it's going to be a rainfall, if wind conditions or so. But given that apart, it's a very, very useful tool for remote sensing. This technology has been quite used for agricultural uses and urban planning. One of the main reasons that you don't use for environmental studies is that environmental studies don't give back money like agriculture or urban planning, for example. So it gets more interesting when you focus that effort and take the study of environmental. For example, you can use sensors, so you can capture a specific wavelength and focus on that wavelength and isolate them and take specific data from that image or from a specific image. You get this is called multispectral sensors. So you get one wavelength, for example, in the green light, one in the blue light, one in the red light, one in the infrared light. So if you get all these images get together, then you get the visible spectrum wavelength or the visible spectrum of light. So the analysis of these images, when you combine them, you can isolate and get specific information. For example, in this case, the NDVI, which is the NDVI, SVI, and also the GSI, sorry. With that said, you can get the evaluation on the health of vegetation by taking these three factors: the chlorophyll content, the structural deficiencies, and also water status. By using these tools and the correct software, you can improve the precision in the evaluation in the state of health of vegetation. So in this case, within an image, you get the chance to take three main spectrums or ranges, which is the visible light, the infrared light, the near infrared, and the shortwave infrared. Within the visible light, you get the chance to look at chlorophyll absorption, and there is so many other activities that you cannot be or cannot be seen within a simple photograph. But by the use of multispectral sensors, you can get this information. As well, for example, then within the near infrared spectrum, you get the chance to detect or identify cell structures, and also within the the shortwave infrared, you get the chance to perceive water content of if there is any water within the field. In this case, we studied two thermal springs. One of them is very, very well conservated, and the other one has been already affected by man. Thank you. So, sorry. Can you see the image? Okay. So, we went to San Luis Potosí, and there was the spring of Taninul, and also the one of Minero Azufoso. One of them, like I said, is placed within a hotel. It is already impacted by man, and the other one is very far, far away from population, and it's not accessible. So this is the drone or the UAV we used with the multispectral camera. What we did is, after taking the photographs, we had to align them. Of course, the photographs or the images had to be overlapped more than 70% frontally and laterally. And the drones were programmed to make their flights, and also the information was processed in the computer. One of the conditions that we had to take care about was the height of the flight. All the flights were carried out at 250 meters. So in order to not be affected by the dosel or by the highest trees, which is, in the case of Minero Azufroso, it was between mountains, so we had to take care about that condition of height. Afterwards, all the points or all the images got together like multiple points, and they were processed with this software of Metashape. So basically, this net of points were processed, and the images were as well uniformized. So images that were very, very bright had to be uniformized with others, and the other ones that were very, very dark had to be enlightened. So the orthomosaic was obtained after the process of these images by using Photoshop software. The orthomosaic is the best quality image by joining all the images together. And also we had to use or to create the DEM, which is the digital elevation model. And these two together were the main basis for this work. So like I said before, we had the images, all of them were processed. As well, they were joined into an orthomosaic, and also the generation of the digital elevation model. So like previously said, we had the chance to export the specific wavelength images, and this is the spectrum, the RGB or red, green, blue spectrum, which it corresponds to the visible spectrum of light, and also the infrared and near infrared spectrum. So with that said, the images will help us to generate the indices of vegetation to evaluate the health, the NDVI, SAVI, and GCI. The results of this work is in Taninul Spring, we could take 2,410 photos, and in Minero Azufroso, there were 3,780 photos taken. Like I said, the overlap of the images was greater than above 70%, and due to the slopes and maximum flight height, we could achieve a pixel size of 5 centimeters in Taninul and 7 centimeters in Minero Azufroso. In Taninul, we can see there is a hotel. If you could please lower the light. I don't know if you can see, but well, we can see the hotel. This is the path or the road where you access to the hotel. This is the parking lot. We can see this area of vegetation, but you can think that this vegetation is natural, but it is not. It's introduced. And this is the size of the other side has vegetation, natural vegetation, but it has already been affected previously. In the next slide, you will see the details of this slide. You can see also the spring here, which is where you can see the water bodies. So these characteristics, you can track them in the upcoming slides. In the case of Minero Azufroso, you can see this is an unaffected area, a natural area. The forest is very, very dense, and the water springs was located over here between two slopes. So you can see there are hardly any roads. You cannot see them. There are no water bodies because of the density of vegetation. So by using the DEM, you can see the highest part in the Taninol Spring was 185 meters above sea level. And in the case of Minero Sufroso, it was 207 meters, were almost the same. In the case of Taninol, you can see this is the hotel. You can see the springs over here and over here. In the case of Minero Sufroso, you can hardly see the spring over here. But when you use the tool and you generate the indexes, and if you get the chance to take a scale like this one, in color red, you might see the lack of vegetation in several areas in the case of Taninol. Also, you can see that the state of vegetation health in general goes in this second level on the range of scale. So the vegetation that you can see is because of the spring water that the hotel personnel does to the vegetation or to the forest, but the natural areas are very, very affected. Also, you can see there are lack of vegetation, which is the red spots over here. On the other side, in Minero Sufroso, you can see that all image goes in green, and there are some dots in black, or there are no dots in blue, so the spring over here, you cannot see it because of the vegetation density. And the spots over here are because the direction of the photograph. So one lesson for this work is that you can take, or you have to take photographs in different schedules or different seasons to get all the information. In the case of Taninol, there was no problem at all because the vegetation was not that dense, and also it was very uniform. The topography was flat. In this case, it was with slopes. The soil adjusted vegetation index can give you the information where there is nude areas or without vegetation. So in the case of Taninol, as before, you can see that there are very, very spread areas without vegetation. Those are the red zones. The green zones, like I said before, are where there are trees and vegetation. In the case of Taninol, there are no red zones. All the photograph gives you the image of green zones, like I said, and where there is no information or there were no collection of data because of the slope and the right reflectance goes in black. And for the last, the green chlorophyll index as well gives you the information where there is photosynthesis or there are chlorophyll activity. In the case of Taninol, you can see that only in those areas where there are trees and there are, some vegetation, you get this scale, so you can interpret that, or the most land area in Taninol gets a value near zero or a small value. So in the case of Minero Sufroso, you can see that it is better or well conserved by using this tool. The conclusions for this work is that there is no single vegetation index that encompasses all the characteristics needed to evaluate the study. The combination of these three indexes provides a good assessment on the state or the vegetation health. Iterating various vegetation indices using spectral information can determine the characteristics health status in the area surrounding hot springs. The use of various indices provides a good interpretation of results in determining the health and status of vegetation. One of the main challenges was during the taking of the images at Manero Asoproso Hot Spring. Like I said, it was between two slopes, so you had to take care of the height and on the top of the trees. The selection of work areas and the altitude at which the images should be captured is a preliminary task that needs to be done at each specific site in order to determine the specific features required for subsequent analysis. And using multispectral images taken by cameras mounted on UAVs enable to quickly assess the health status of natural vegetation in areas of concern, which better spatial resolution that they provided by the satellite images. Thank you for your attention, everybody. Our data is on the screen. My name is Edgar Salmerón, and I am from Corporación Ambiental de México. Thank you very much.
Thank you very much for your presentation. So, we have time for only one question. If anyone has additional questions, we invite you to contact to our speaker. So, is anyone interested in asking one question? Well, please.
Thank you so much for your presentation. Just one quick question. Are the data open? Yes? Yeah, I said, are the data open, the images? And what is the special coverage of the images?
Thank you. The question was, are the images open? Yeah. Currently, they are not. But and recently we will share them with the community. We have already shared, we are still working with the data in order to publish them in magazines. But yes, hopefully we will have them available to everybody. Clarify.
This work is part of a bigger group of investigations, researchers that are being conducted in hot springs, geologically, hydrogeologically, and ecologically as well. So we are, this is a small portion of the whole research that we are conducting through the help of the Universidad Autónoma de Tamaulipas. Thank you.
Thank you. Thank you.
So just to end with this presentation, we want to extend our gratitude to our speaker. So we want to express